Okay, so this chapter is about networking protocols and threats. So we're going to kind of take the stuff we talked about in the last chapter about, basic networking, which should have been for the most part a review for y'all. And we're going to look just a little bit further at some of the attacks that take place on a network. So we're going to talk about ports and protocols and how to identify those. And we'll talk just a little bit about some of the major types of network attacks. Now, this should be a review for a lot of you. A TCP IP address has a port associated with it. And a port is a way that a service is open on a machine for a network connection. 0 to 1023 are the common ports. Some of those you should know by default, like port 80. You should know that port 80 is web traffic, or port 443 is secure web traffic. Anything from 0 to 1023 is considered the well-known ports. That's where a lot of common things are. From 1024 to 49151 is the registered ports. And there are lots of services there that are common. They're just higher numbers. An example, how many of you have used remote desktop? That uses port 3389. And then 49152 up to 65535 are the dynamic and the privates. Those can be used for anything. As an example, when you make a connection to a web server, you make the connection to the web server on port 80, but the web server returns data to you on a random port that's in one of those dynamics, unless it's told specifically not to. Also remember the TCP and UDP. The differences in those, because different services use different versions of those, or different TCP or UDP. What I mean, for example, is DNS, which is a really common one, uses UDP port 53, where HTTP traffic, your web traffic, is usually port 80 and it's TCP. There's a list in the reading that you can look at, and at this point you don't really have to memorize all of them, but take some time to learn the really common ones, because you'll see those on any of these CompTIA exams that you take. Like if you go back and take Net Plus or any of those, they're going to talk about the really common ones. As you go further into this, knowing what port something comes from doesn't necessarily tell you that it's that traffic, because it doesn't have to follow the rules. But generally it would be. If you generally see something on port 80, it's generally HTTP traffic, for an example. And then inbound and outbound. Again, an inbound port being like, you're connecting into a service, port 80. Outbound being a complete dynamic port that it picks to send data back to you. So one of the most common types of attack on a network is called a denial of service. And this is a very broad term for just attacks that make a resource unavailable. Generally, a denial of service is where you send information to a website or a server, be it some other service. You send so much to it that it can't respond to actual real traffic. A very simple example might be that if we had a wireless server in here, which, I mean, you really shouldn't have a server wireless, but for purposes of example, if we had a wireless server in here and we had these computers all try to connect to the web server on it at the same time and just send tons of data that was pointless, random data to it. Well, if it were wireless, even with just the 13 machines in here, we probably could get enough traffic to it that the server then couldn't respond to normal traffic, to actual traffic coming off the internet. And if that's the case, we've essentially shut down the server with a distributed denial of service attack. The actual DOS here is just one machine attacking one other machine. And generally, you don't get enough from a single machine for it to be worthwhile. This is where if you start digging into a lot of things that like malware and such does, this is where a botnet comes into play. If I can manage to get access to, say, 1,000 computers, which is even a low number, more like 10, 15,000, and then I want to attack CNN.com, and I have all of those machines send web traffic to CNN as fast as they can, I may be able to shut down CNN.com because it can't respond to normal traffic. This is the type of attack that happened here, I believe it was last semester when Lonnie went down. There was a ping flood specifically on one of their routers that routes stuff up to us on the network from Baton Rouge, and that's what shut the campus down, what shut down the whole state, because it was one of the routers coming in. So the different types of attacks, this is just a list of them. I'm not going to go into the details on all of them, but if you do the reading, it's going to go into them and more. A ping flood is just exactly like it sounds like. Y'all know the ping command. This is where you're sending ping as fast as a machine can respond. And if you're sending it from enough machines at one time, you can flood it where it can't get any other data out. There's a Smurf attack, a Fraggle. That one's kind of interesting. That's where you fragment TCP packets and you send so many of them and in such a weird order that the machine spends all of its CPU time trying to put them back together. The Christmas tree attack is another one, a ping of death. A permanent DOS, that's where you just continue and continue, and then a fork bomb. So here they're talking about distributed denial of service that I just mentioned. That's where you use more than one host, and that's really the only way to successfully do a DDoS attack. One of the interesting things about DDoS attacks is that there's really not a foolproof way to protect against them. You can't shut down those services because that's what you're, making your money off. That's your mission critical. Think about like CNN.com again as my example. Their website needs to be online. If you're going to CNN.com to consume that content, they're making their money because of the ads on that content. So it's not like they can shut down the web server to keep this from happening because then the service wouldn't be available. Another type of attack is a sinkhole and a black hole. A sinkhole is a DNS attack where basically you send a request to a DNS server and it responds with false information. Not unlike a man-in-the-middle attack, or this is usually a piece of that. If I'm going to do a man-in-the-middle, I need you to go to my DNS server and get false information to go to my fake web server. So that's where a sinkhole comes in. A black hole is very similar, except instead of giving out bad information, it just doesn't give anything. They call it a black hole because literally your packet's just disappearing. And if you'll think back to when we started talking about networking in your networking classes, with TCP, you remember that three-way handshake we drew out. Well, if you don't get a response from the acknowledgement, you'll send it again, and you'll send it again, and again. And if I'm not sending anything, it's just a black hole, your system will spend more and more time trying to send that data. And then finally, there's a session hijack. And a session hijack is where you exploit a computer session that's in progress to try to gain access. They've got some examples here: clickjacking, a watering hole, a session theft, TCP/IP hijack. One that I'm somewhat familiar with is an SSH hijack, where you try to, if you are in the right spot on the network and you can gather SSH traffic, basically if somebody walks away and leaves their system and I can pull that traffic and make it look like it's coming from me, I may be able to hijack their session. And in a Linux machine, if I hijack their session, that means I'm going to get a prompt on their computer, their server. If I luck out and they were, root at the time, I've really hit the jackpot. But if not, I've gotten access to the system. Maybe I can become root and do some other things. So other types of attacks, a spoof. This is not unlike we talked about Mac spoofing before. This is when you masquerade as another person by falsifying some kind of information. If you are learning about a network, and this kind of gets into like the CEH class where we start talking about actually doing an attack. But if I know that your network is locked down by computer name, which is an odd thing to do, but okay, for our example, we're going to say computer name. I can name my laptop something that is a valid name on your network, and if it allows me into your group policy, then I've gotten access to your network by spoofing the name. This is most commonly done with a MAC address. Lots of networks will lock down the network based off of MAC address. And that is a nice added piece of security because Joe Blow off the street's not going to be able to change his MAC address, but it is by no means something that should be secure because, as we mentioned before, there's a program you can put on a PC to do it, and on a Mac or on a Linux machine, it's one line of code to change the MAC. A replay attack is where you are able to capture data on a network, and you send that data back to the server again, and you gain access to the server because it has the credentials in it that allow you on the network. These are most commonly done on Linux machines, again, to get access to a shell. A null session. A null session is an attack that luckily Windows has mostly fixed at this point. And I don't remember the exact line, but basically all Windows servers have a share called IPC $. And in the Windows world, any network share you create with $sign doesn't show up on the list, on the browser list. So you could connect to IPC $sign as a guest on most Windows machines, and it would give you a little bit of information on that machine, like the users that were on it. And sometimes you get lucky and find public shares and things, which, again, may not lead you anywhere, but may gain you access to that server, and then you can try to escalate your privileges a little more. We tried that in the CEH class the other day on the Windows 2016 server, and it doesn't work anymore, which is good. It used to work on 2008, so maybe they've closed that hole. And then transitive access and client-side attacks. This is just a way of attacking a computer from something on the network that would otherwise be considered harmless. So DNS poisoning is not unlike a sinkhole that we talked about earlier, except instead of running my own server and trying to get you to connect to it, I get the cache on your DNS server to hold fake information. This is usually the first part of getting your users to then go to, a site that looks legit, like a phishing attack, to get them to connect up and give me some information. Domain name kiting is another one. This is not unlike a DNS poison, but for domain names at an Active Directory level. And then ARP poisoning is also along these lines. How many of y'all remember what ARP is? Come on, think about your networking class. What's it stand for? All right, one of y'all Google it. Address Resolution Protocol. You're close. You said relay. ARP is what, if you will remember, changes MAC addresses into IP addresses. If y'all remember way back when you're thinking about the level of a computer on layer 2 in the OSI, when you're actually sending data to a computer, you're looking at a MAC address. Well, data is coming from the servers and everything else at an IP address. All an ARP table is a list of IPs to MACs that your computer is seeing. In fact, if any of you open a command prompt on the machine behind you and type ARP-A, you'll see the list of stuff that your machine is seeing right now. Well, an ARP poisoning attack is where I try to make your computer look at that table differently and think that my address is the valid TCP IP address. So that is in a nutshell some of the different types of attacks. We didn't go into any of them in detail because at this level and on the Security Plus test, you really just need to know the different types. You don't really have to know the details of how any of them take place. Now, the reading will give you a little bit more on them, and the labs, which I certainly hope they get fixed, some of these labs have some of those attacks, so you can kind of take a look at them. Again, review the key topics, look at your key terms, answer the end of lab questions. If the labs will run, try to do them. If they won't, look at the specific labs, and if there is one that y'all want to see, I'll see if we can't duplicate it in this room. One of the great things about this lab, again, is that we're off the campus network, so we can do one of these. Like we could do a really small DOS attack if y'all want to see how it works. We'd have to probably do wireless because we don't have enough machines to really attack anything. And that's this chapter in a nutshell.